Welcome back, Mindsetters. If you have just joined us, we are doing maths for grade 10, and today we're continuing from last week, and that's with trigonometry. For those of you who have been here, I know that you've been having a stunning show, and I hope you keep your focus up, guys, because this is such an important show, and trig is such an important section, and I know many of you are loving trig, so it's good to have you here. Over to you, Dina.
Thanks, Katlehu. How are you doing on that first challenge question? You've got some answers yet? Remember, you're not allowed to use your calculator, so you need to develop some technique, some tool to help you that won't use the calculator. Certainly you can touch it and work with it, but not in terms of your methodology in arriving at a solution. Well, I'm thinking that we've covered so much trig that it's time for a next challenge question before we get on to the next problem involving the application of trig. So the next question is an equation, and you are required to solve for A. And the equation is as follows: 2 cosec of 3a minus 42 degrees equals to 2,486. With this question, you may use the calculator. What is the value of a? If the equation is 2 cosec 3a minus 42 degrees equals 2,486. Have fun solving for a. Right, we're going to go on to our next problem, which is not that one, which is this one. Right, here's a story. Usually, if you're involved in some branch of mathematics, people will call on you to help them solve certain problems, and here's one such problem. We have a vertical cliff, and this vertical cliff is 235 meters. Now, somebody on top of the cliff sees, and this symbol over here is just an angle symbol, angles. So from the top of the cliff, this person sees two boats at sea, and the angles at which he sees the boats are 32 and 47 respectively. And our job is to find out how far are the boats from each other. Okay. So you kind of scan for the important information. You can visualize there's a vertical cliff, there's boats at sea, watching the boat and want to find out the distance. So in mathematics, in fact, in any problem-solving scenario that you do, you scan for the initial context to determine where you are, what it looks like, etc. Then you want to read a second time. But this time you're going to try and focus on those key words that will give you extra meaning and an extra dimension to your problem. And those are things like, why are we told about a vertical cliff? Or why are we told about a vertical height of a cliff? Is that important to us? And we're told that it's above sea level and it's 235 meters. Well, it is, because cliffs need not necessarily be vertical. So a vertical cliff basically means that something is standing perpendicular to its base. And if it's not perpendicular, we're going to get a very different diagram. So it's important to understand the mechanism of how these shapes are actually formed when we're actually drawing them. Vertical means that they are perpendicular to any base that they are standing on. Right, so vertical is very important. We're talking about something that's perpendicular. And we're also given that this cliff is obviously above sea level. Then from the top of the cliff, somebody sees two boats at sea. And then we've got these words, the angles of depression. What do we mean by angles of depression? That's a very particular mathematical terminology, and it's got a very special meaning. And it means that if somebody is watching straight ahead, that would be horizontal, that's towards the horizon. The moment you take your eyes down from the horizon and you look down, that line of sight will have changed by an arc, and that's the angle that we talk about as the angle of depression. If we've got our line of sight and we're looking up, then that angle we talk about is the angle of elevation. So we need to know where the horizontal is so we can measure an angle of depression or angle of elevation. So those are very particular mathematical terms. So we've got the angles of depression, and we want to calculate the distance between the boats. So let's try and draw this. What does this look like mathematically? So we're going to set up our cliff. There's our cliff, it's vertical, so means to the sea it's at right angles. And this cliff is 235 meters. And somebody then stands on top of the cliff and they look down at a ship. Okay, so here's boat A. When he looks down, and this is our line of sight, it means that he's looking down measured from a horizontal that's coming parallel to that bottom. So at the moment I'm just getting a sense, I'm not drawing anything mathematically and nothing fancy here, I'm just getting some direction as to what's happening. There's my horizontal, and my horizontal would be parallel to the sea, and when he sees that first boat, the line of sight has been measured from looking down from the horizontal. But then he sees a second boat. Okay, we're going to call that boat B. And the closer the boat is to the cliff, the bigger the angle of depression. Okay, so our job is to find how far are those boats from each other. Okay, so just to get the dimensions again, we go back and we read it again. We've got the dimensions for the vertical cliff, but we've got that the angles of depression are 32 and 47. So let's go and put those on the diagram. So this one is 32 degrees, and the closer boat to the cliff is 47 degrees. Okay, so just very roughly, two boats at sea, I'm on the cliff, I see boat A, boat B. Let's put this into some mathematical perspective. So if I was to just draw a mathematical picture, I've got something of this sort. I've got boat A over here, I've got boat B over here, I've got a horizontal that the observer is measuring the angle of depression from, of 32. I've got another boat at 47, and I've got this cliff at 235 meters. Okay, and very important, I've got that vertical cliff. So mathematics, things aren't given just because they're sitting pretty there. They've actually got some meaning, some impact. Right, so our job is to find this length here. Okay, now it's very interesting that again, notice that AB is part of this obtuse angle triangle. Can I do anything with obtuse angle triangles? No. So I've got to break my picture down into smaller units of right angle triangles. And so I'll begin with something as simple as, if this line, if the horizontal is parallel to that ground, then do you agree that B2 has got to be 47? In fact, it is true that if there's an observer and he looks down at an object, from that object, if you look up at the observer, the angle of elevation will be the same. So if I look down, somebody else looking back up to me, then the angle of elevation is 47. So these lines are parallel, the alternate angles are equal, so that's 47. And I've also got that this line is parallel to that one, so this angle of depression will equal to the angle of elevation from A. So I've got those. Now, by just filling in those two very prominent angles, we've actually created some very nice right angle triangles here that we could utilize. So what is it about this blue triangle that would help me in getting closer to AB? Well, firstly, I could find this length over here, and I'm just going to call this P. So I could find PB. At the same time, if I wanted to find out what the whole length AP is, I could work out in the green triangle, I could work out what that length was. Does that help me finding that white length AB? Certainly it does. Okay, so notice how the picture started off by wanting us to find what AB's distance is. But it was impossible, so we broke it down into right angle triangles. The the blue one and the green one, they're both right angle triangles in which we could find information that would ultimately be able to find what the length of AB is. Okay, right, so we've now got some calculations to do. So in the blue triangle, we've got 47 degrees is my focal point, or it's my focus, or it's where I'm at. And I would like to find out what PB is, which in relation to the angle I've chosen is my adjacent, and the 235 which is given is my opposite. So which ratio connects opposite and adjacent? My tan ratio. So therefore in the blue triangle we're going to have that tan of 47 is equal to opposite, which is 235, over PB, which is what I want to find. Now again, notice if my denominator is my known, then I'm going to multiply both sides and I'm going to divide by tan 47. So I'm going to do this in two steps. PB tan 47 will equal to 235. And then if I want to isolate PB and solve for PB, I'm going to get 235 divided by tan 47. And let's get rid of this little degree here because he shouldn't be there. Okay, right, so there we are. So we can now use our calculator, and we have 235 divided by tan 47, and that gives us 219,14. So PB is 219,14. Okay, so that's this length here, 219,14. Then I've got the green length AB. So the green length is now in this big triangle. So 32, always go and find your position of the angle. I'm sitting at 32. What do I want to find? My adjacent. What have I got? My opposite. So which ratio connects adjacent and opposite? It is my tan ratio. So tan of 32 is opposite divided by AP. Again, can you see the same scenario? We have a denominator AP, so we're going to take AP to the other side, multiply by tan 32, and then we want to solve for AP, so we want to isolate AP, which is 235 divided by tan 32. So we now have, our calculator will give us 235 divided by tan 32, giving us 376,01. 376,01. Okay, so that is this length here, 376,01. Okay, so no prizes for guessing. How am I going to work out what that little leftover bit is? It's my green minus my blue. So in the end, the length I'm looking for is my 376,01 minus 219,14. So the distance between the ships minus 219.14 is now 156,94. So 156,94. And I think it was in meters because the vertical cliff was 235 meters. So there we go. We've been able to, what we've done mathematically is what we call modeling. We've modeled what was in words into a mathematical diagram, and we've been able to use trigonometry to help us to find the length between those ships.
Thank you, Dina. So guys, we are going to go for a really quick break. Get refreshed, get revitalized, but do it right on your seats. Do not move because we are back with some more interesting trigonometry. See you now.